Hello everyone, welcome to GATE Academy Global. How are you all? I hope you are doing good. So please tell me my audio and video are clear or not. So please confirm once. After that we will start our discussion. So good afternoon everyone. Good afternoon Shiva and Das, Gopi. Yes, Thiru, I will complete it. Complete the series part, electrical machines. Okay. Very good morning. Sorry, very good afternoon. Okay. Please confirm once audio and video clear or not. Thank you, Thiru. Thank you very much. Okay. Okay, listen. In previous session, I had discussed about the working of the three-phase induction motor. So that is exactly the working of three-phase induction motors. So in this session, I would like to discuss about rotor-fed three-phase induction motor. The first question in your mind, that is what is mean by rotor-fed induction motor? Is there any differences constructionally between the stator fed induction motor and rotor fed induction motor? Constructionally, there is no difference between stator fed three phase induction motor and rotor fed three phase induction motor, but the way of input is given to the machine is the different. In the stator fed three phase induction motor, the three-phase supply is connected to the stator terminal, whereas rotor fed three-phase induction motor, three-phase supply is connected to the rotor terminal through slip rings. So this machine, or this is a rotor fed three-phase induction motor, is rotor fed is possible in the slip ring induction motor only, but not in the squirrel cage induction motor. So this first point, it is a possible in the slip ring induction motor only, but not squirrel cage induction motor. So what is exactly rotor fed three phase induction motor? As I earlier mentioned, the rotor fed induction motor, the supply, three phase supply is given to the rotor terminals. That means rotor winding is excited with the three phase supply, whereas the stator winding is provided with some closed path to flow the stator current. So this is the main constructional details of the stator fed three phase induction motor and rotor fed three phase induction motors. So in this case, so rotor winding, already I have mentioned that any induction machine has two major parts. There are two windings. One is the stator winding. So this one is a stator winding, and second one is rotor winding. So stator, in the previous case, in case of this is in case of stator fed induction motor. So I will differentiate first. So what is the stator fed induction motor and rotor fed induction motor? the stator fed the induction motor. Fed means giving supply here. The stator fed induction motor. So here supply is okay, 3-phase stator winding is excited with the 3-phase supply. So this is the stator winding is excited with, okay, this is the excited. So with 3-phase the supply, whereas rotor winding, what will happen here? So rotor winding, okay, is the shorted. So it is a shorted to provide the closed paths, okay, shorted. So with the slip rings, with end rings, got it my point? So here end rings, okay, it is a shorted with the end rings. So here is this is the in case of the stator fed induction motors. So what will happen in this case, the rotor fed induction motor? So is it supply given to the stator winding? No. So we are not going to give the supply to the stator winding. Just we are going to give the supply to the rotor winding, whereas the stator winding is a shorted with the end rings. So now this one is so similarly in case of the rotor fed induction motor. So what will happens? Okay, listen, induction motor. So here rotor winding is excited with the 3-phase supply. So this rotor winding is excited with, okay, 3-phase the supply through slip rings. So next stator winding is shorted, okay, to provide the closed path to flow the current. So this one is shorted by end rings, okay, as like the rotor winding in the stator fed induction motor. So these are the two differences between the stator fed induction motor and the rotor fed induction motor. Is that clear everyone? So the constructionally, that's why, so exactly inverse process. Here supply is given to the stator and current passes to the stator winding and produces magnetic field, okay. So this supply here, what will happen? So initially 3-phase supply, so this 3-phase supply is given to the stator, so due to which, so given to the stator winding, so then what will happen? The rotating magnetic field, so RMF, the in stator rotating magnetic field will be produced in the stator. So this the rotating magnetic field is cut by, so this RMF, stator RMF, so is cut by, okay, which conductors here? So cut by the stationary, the road, this is the stator, the stationary, the rotor conductors, rotor winding or rotor conductors. So due to relative motion, okay, this is the due to the relative motion between the stator RMF, already we have discussed this point, the stator RMF and the rotor conductors. So then what will happen? So EMF induce, okay, in the rotor. So got it? So due to the rotor induced EMF, the which in turn produces the current in the rotor winding. So this EMF I can say here E2. So then the current passes through, rotor current, okay, passes through the rotor winding. So which you can denote it by I2. So this rotor current, okay, create so flux in the machine. So rotor flux. So this rotor flux also rotated at a speed of the ns. So that's why you can say that rotor RMF here. So this is also, okay, this stator flux rotates at a speed of the ns and this is also rotates at a speed of the ns. So due to which electromagnetic torque produced, that is the electromagnetic. So this electromagnetic torque drives the rotor of, okay, rotor of, so 3-phase induction motor. So in direction of, which direction? In the direction of the rotating magnetic field. So at a speed of, so at a speed of the n. So this part, so completely it is a stator fed induction motors. All of you got it point? So already we have discussed this part. Yes or no? So this is the step by step procedure in case of the stator fed induction motor. Is that clear? So already we have discussed this part. So what will happen in case of the rotor fed induction motor? So that part, similar way, suppose here 3-phase supply is given. Okay, this 3-phase supply is given to the which part? Okay, rotor winding. So that rotor winding is excited with the 3-phase supply. So this rotor winding is excited, here windings also physically displaced by 120 degrees and current passes to this rotor winding also time displaced by 120 degrees. So that the flux is produced in the rotor, so which rotates at a speed of the ns in the air gap here. So that we can say it is a rotor RMF. So due to this relative motion, so here EMF induces, okay, in this case, so EMF, this rotor EMF induced in the stator, okay, here this EMF induced in the stator, similarly EMF induced in the rotor part, okay. So this stator EMF produces the current I2, so that is a I1 amount of the current. So now this current create the one more flux in the machine, so that is a phi 1. So what will happen? This flux is also, if the stator windings are physically displaced by 120 degrees, so this is also rotating magnetic field. So the interaction of the force, okay, between the rotor flux and the stator flux, electromagnetic torque produced. So due to this electromagnetic torque, so now this rotor will be rotated, okay. Now can you tell me, is it rotates in the direction of the rotating magnetic field or opposite direction of the rotating magnetic field? So let us know about this part, whether it is rotates in the same direction of the rotating magnetic field as like a stator fed induction motor, or rotates in the opposite direction of the rotating magnetic field. So that part we are going to be discussed in this session. So exactly process point of view, see here. So here process exactly is the inverse process. So are inversely here. So first supply is given to the rotor RMF, the stator RMF, the interaction force between these two fluxes, electromagnetic torque produced. So this electromagnetic torque definitely drives the rotor, but at what speed and at what direction, whether it is in the clockwise or in the anti-clockwise direction. So that part we are going to be discussed in this session. So exactly this process is a inversely process, so inverted process. So that's why this motor is also called, another name of this motor is so it is also called, so inverted 3-phase the induction motor, okay. This is the 3-phase induction motor. Another name of this is a inverted 3-phase induction motor. So what is the reason? The whatever process occurred in the stator fed induction motor, so and what is the process of the rotor fed induction motor? Exactly opposite. So that's why you can say, so this is the inverted 3-phase induction motor, and this is the stator another motor is the stator fed induction motors, okay. Is that clear everyone? We will discuss in details, but I will tell you, just had mentioned that why it is called inverted 3-phase induction motor. Okay. So now this is possible in the slip ring induction motor only, but not in the squirrel cage induction motor. What is the reason? So in the squirrel cage induction motor, there is no external, okay, external slip rings are provided, so that we cannot provide the 3-phase supply to the stator winding. So in the squirrel cage rotor, rotor copper bar itself act as a conductors. Okay. So now let us take slip ring induction motors. So we have, so this is the rotor of the shaft of the machine. First let us take, so this one is so I can draw here shaft of the machine. All of you look at here. So this is the shaft of the machine. So on the shaft, so we are provided, okay, this is the shaft of the machine, okay, we are providing the shaft of the machine. So next one, so on the shaft, okay, we are providing some slip rings. How do we place the slip rings here? So this is the one slip ring, okay, otherwise I will take this part. So it is the slip ring 1, okay, slip ring 2, and this one is the slip ring 3 here, okay. So these slip rings are provided on the shaft of the machine. So here slip rings, okay, are provided, and we have a rotor winding. So how do we take the rotor winding? So this one is just assume, so rotor is placed, okay, like this. Okay. Okay, just assume this box is a rotor, and on the rotor there is a stator winding. So this part I can draw here. So it is a stator part. Okay. So now this supply, yes, there is no supply here, I will show you clearly. So what will happen here on the rotor, we are providing the windings. So windings are provided, okay, like, so this the rotor winding 1, so A phase rotor winding and B phase rotor winding, and this one is the C phase rotor winding. So this is a first here, it is connected like, so this part is a connected, okay, it one, and second one, okay, it is connected to the slip ring 1. So assume another phase of the winding, rotor winding, is connected to another slip rings, and this is a connected to the slip rings here. So now 3-phase supply is given, okay, through the slip rings. So this is our 3-phase supply, 3-phase AC supply here. So that 3-phase current, okay, passes through the slip rings, okay, this is the, so it is a, okay, this part, okay, this complete part I can say, so it is a rotor box, okay, this first box is the rotor part, and this one is a rotor winding, okay, got it my point? So this rotor winding, A phase winding, and so that current passes through the rotor, okay. So this rotor winding also physically displaced by one. So this part I can say it is a stator, okay. This stator also contains similarly the stator core and stator windings. So how do we represent this, okay, exactly diagram point of view? So now this rotor part I am drawing extra here. So let's see here, how do I draw? So for example, this rotor core is a slots is equal to 12, and what about the phase here? 3 phase, okay, this rotor winding, the rotor, the winding. So I am drawing here this rotor winding clearly. So slots I have taken 12, or let us take 6, so that is enough, okay, for this case. So we have taken 6 number of the slots, okay, is that clear my point? The slots is equal to 6, and each slot contains single conductors. So that's why how many number of the conductors? 6 number of the conductors. So this is the rotor winding connections, how do they are connected? So listen my point. So now number of poles, assume as this poles is equal to 2 pole machine. So that slots per pole is equal to, so this is a 6 by 2, so is equal to 3 number of the slots, okay, slots per pole. the here this is the 3, and conductors per pole here similarly 6 by 2, so it is equal to 3 conductors. Now next one, the slots per pole per phase, okay, here also. So how many conductors per slots per pole per phase? So this I have taken the 6 3 by 3, that is equal to 1. So we have a 6 slots and the 6 slots and the 2 poles and 3 phase machine. So that is a 1 conductors here, slots per pole per phase. So now let us draw in this case. Suppose we have, okay, this is the rotor, okay, the slots, okay, I have taken rotor slot. All of you clear point? So this one is a rotor slots. So I have shown like this. So this rotor slot. So what about the first slot? So I am placing this is the slot 1 and slot 2, okay, this slot 3, slot 4, okay, slot 5 and another slot, the slot 6. So now let us place the conductors in the slots. So this is our first conductors, right? So conductor 1, is it clear my point? So this one is the conductor 1, okay, I am placing conductor 1. So now conductor 2, okay, I place the conductors like this. So now this is the conductor, okay. So now conductor 1, conductor 2, conductor 3, conductor 4, conductor 5 and conductor 6 number of the conductors. All of you got it? So 6 conductors, let us give the numbers 1, 2, 3, 4, 5 and the 6. So these conductors, 3 conductors are under the influence of the one pole, let us assume north pole, and another 3 conductors are under the influence of south pole, let us assume south pole here. So is that clear? So first conductor is connected to, so if coil span I have taken the coil span of the winding, so that is equal to 3. So first conductor is connected to the 4th conductors, got it? So this is the starting end of the A phase and this one is the finishing end of the A phase. That's why you can say A1 and A2 terminal. Similarly, after 120 degrees, that is the slots per pole, the here slot angle is equal to, how do we get slot angle? The slot angle, so it is a 180 degrees divided by slots per pole, generalized formula. So totally the 360 degrees, so that each slot occupied by 60 degrees. So now this is equal to 60 degrees, 60 degrees. After 120 degrees, it is a B1, okay, and this one is connected to the 6th conductor. So this is the B1 terminal and the B2 terminal. So this is the C1 terminal. So 5th one is connected to 2nd conductor. So it comes from the 5th, okay, here from the 5th. So now it is connected to the C2 conductor, okay, C2 10. So now how they are connected here? So this A2, okay, B2 and C2. So are A1, B1 and C1. So this A1 and B1 terminals are, okay, this A1. So this let us provide. So here we have a shaft, okay, this is the first slip ring and second slip ring and third slip rings like this. So now these are the provided on the shaft of the machine, okay, this one is so provided on the shaft, okay, like, so we have a shaft of the machine, suppose we are provided on the shaft of the machine, got it point? So this A1 is connected to the, okay, this A1 terminal. So is connected, okay, connected to the first one, and A2 is this is B1 is connected to the shaft and C1 is connected to the slip rings. So these are connected to the 3-phase supply. So this is the 3-phase the supply. And so what about the A2 and B2 terminals? Okay, this A2 and this is the B2. Okay, these are connected to the neutral point. Okay, here is a neutral. So this same winding I have shown here, okay, this is, so in this box, so it is a 3-phase winding, supply is given to the 3-phase winding, okay, is that clear now? Now here also the stator also same. So we have a stator winding connections. So this one is the stator winding. So how they are connected? So suppose here stator poles, okay. So S is equal to stator poles is equal to 12 and the Z is equal to 12 number of the conductors and number of poles I have taken 2 number of the poles per our convenience. So how many number of the slots per pole? The slots per pole is equal to 12 by 2, that is a 6. Now slots per pole per phase is equal to 12 the divided by 3, so that is a 6 by 3 is equal to 2. So now slot angle is equal to, okay, how do we get slot angle? So this slot angle is equal to angle occupied by the each slot. So 180 degrees divided by slots per pole. So 180 degrees divided by slots per pole means 180 degrees divided by 6. So it is equal to 30 degrees. So now let us assume here coil span, if coil span, so that is equal to, okay, this coil span have taken, so that is a 6, right? So 6 armature, S by pole is equal to 6. So coil span have taken 6 1. So now we have taken, suppose the first conductor, 6th 1, 2, so 3, 4, 5, 6, 7, 8, the 9, 10, 11 and the 12 conductors are there. So in these 12 conductors, so first 4 here, this is the under the influence of, okay, let us assume 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 11 and 12. So this is extra conductor, it is not, okay, 12 conductor, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are under the influence of, so this pole is a under influence of the one pole. Okay, assume as north pole, and these are the under the influence of another pole, it is assumed as south pole. So this is placed in the slots, okay, it is a slot 1, slot 2, slot 3 and 6 number of the slots. So I am placing like this, all the slots are provided. So slot 1, 2, 3, 4, 5, the 6, 7, 8, 9, 9, you can take 6 also, I have taken the different number of the slot. The stator slots is the 6, rotor slots is the 6 number of the slot. So in this case, okay, first conductor is connected to the 7th, right? So this 7th conductor, so 7th one is connected to the, okay, this 7th one connected, so to second conductors. Now second conductor is connected to the 8th. So this is a phase winding terminal. So this is the A1 and A2 of the stator winding. So now after that, okay, this 5, the 5th conductor, it is a B1. So this is the 5th is connected to, so 11th conductors, okay, this 11th is connected to the 6th conductor, so 6th is connected to the 12th conductor. So this is the B1 and the B2 terminal. So this next one, 10th conductor, it is a C1 and it is connected to, okay, first 3rd conductor. So now from 3rd, okay, it is connected to the 10th conductors. So now this 10th conductor is connected to, okay, 10th from the, so 3rd conductors. So now this 10th conductor is connected to the 4th conductors. Now it is a connected, the 4th, from the 4th you can say this is the C2 conductor. So here is a, how they are connected in the stator. So A1, B1, C1 and C2 is there. Suppose we have a, so this is the A1 terminal, A2. So this one is a B1 and, okay, it is a B1 and the B2. So all the B phase and C phase, okay, C1 and the C2. So it is, if it is connected in the star, suppose these are connected here, so the neutral point and these are the short, or otherwise if it is connected in the delta, so then what will happen? So this A1 terminal is connected to the B1, so B2 is connected to the A1 and then A1 is connected here. So completely these are the provided the closed paths, okay, this one is a stator wind. So we have a rotor winding as well as a stator winding. So then what will happen? One by one step we will discuss now. So is that clear now? A supply is not given to the stator, only supply is given to the rotor. The simply rotor is a winding is present on the rotor, so which is connected to provide the closed path. Okay. So now I think you are clear about this winding part. So this is the first one, the rotor winding, the stator winding, and also the stator winding. Yes or no? Okay. So now let us discuss about what about the working. How does it is operated? Okay, the working condition now we will discuss. Working of the rotor fed induction motor. So we have a stator part. Suppose this, let us assume it is a stator, okay, and the complete the stator part. Okay, this is the stator part. So next one, we have a some air gap between the stator and the rotor. Okay, this is the air gap between the stator and rotor. So now this rotor part I have shown like this. So this one is a, so it is a, okay, rotor part point of view. Okay, so this is a stator part. Okay, this is a completely, so I have shown, okay, conductors are present on the stator like, so this is a, I have shown like 1, 2, 3, okay, all the conductors are provided. Okay, first conductor, second conductor, third conductor, okay, fourth conductors, fifth conductors, sixth conductor, like so on, we are placed like this, seventh conductor, eighth conductor, ninth conductor, okay, 10th, 11 and 12 number of the conductors. Okay, got it point? So this we are placing 12 number. And what about the rotor conductors here? So we are placing the rotor conductors. So like 1, okay, 2, okay, and this is the 3 and 4, okay, 5, 6 and 7 number of the rotor. So this part I can say here, so it is a rotor part. All of you got it point? So this one is a rotor, okay, and it is a stator. And what will happen? Okay, this is a gap between these two parts. So it is a air gap, okay, between the stator and the rotors, between stator and the rotor. So now supply is given, okay, here. So these windings are provided. So supply is mentioned on the shaft of the machine. So where is the shaft here? This part is a shaft, okay. So this part I can say, so here, so this part is a shaft of the machine. So where is the shaft? Okay, this part, okay, this one is a shaft of the machine. Okay, is that clear my point? The shaft, the rotor and also stator. So now slip rings are provided in this case. So we have a slip rings. So slip rings are provided on the shaft of the machine. The first slip ring, the second slip ring and third slip rings. So these are connected to the supply. So we are connecting 3-phase supply. So supply are connect, and these are connected to the rotor parts. Okay, like so all are connected to the rotors. Got it my point? So current is passes to the this rotor winding. So now let us discuss one by one point. So it is our 3-phase okay supply. So then what will happen? So first tell me one by one procedure. So whenever rotor is excited with a 3-phase supply, is that get clear my point? So windings also displaced by, okay, it is a, suppose in this case, so it is a okay, and A1 okay, A2 terminal. So this is the B1 and the B2 terminal, and this one is a C1 and the C2 terminals. So we are providing like this, okay, 6. So each phase of the winding displaced by 120 degrees. And what about this current? So this current is equal to, okay, here IA is equal IA and IB. Suppose this IA is equal to the Im sin omega t, and IB is equal to Im sin the omega t minus 120 degrees. IC is equal to Im sin omega t minus 240 degrees. Like this we are placing. So IA, IB and IC. So at standstill condition what will happen? So whenever 3-phase supply here, 3-phase supply is given to the rotor, right? So here given to the rotor winding, okay, rotor winding. So due to which, okay, so flux is rotating magnetic field, the rotor rotating magnetic field produce. So which rotates at a speed of, okay, at what speed here? The rotates, okay, rotates in air gap, okay, this is the air gap at a speed of, okay, at speed of the ns, okay, this is a very important. So it rotates at a speed of the ns in the air gap. So as like a stator RMF in the rotor fed, the stator fed induction motor. So this rotating magnetic field, so cut the two parts. Suppose we are, so this cut the rotor conductors, okay, rotor conductor. So that is the stationary, the rotor conductors. So similarly the stationary, the rotor, the stator conductors. Got it point? So what about the speed in at standstill condition? So at standstill, okay, this standstill condition, that means the rotor at rest position. So what is the speed of the rotor? The speed of rotor is equal to 0. So there is no speed at that discount. So now rotor MMF rotates, rotor RMF rotates at a speed of the ns, but rotor speed is equal to 0. So as a result what will happen? Okay, EMF induces in the rotor. So this is the rotor EMF. Okay, EMF induces. So is that clear point? So this EMF induced in the rotor as well as the stator also the EMF induced, okay, in the EMF induced in the stator. Got it point? So when EMF induced in the stator winding, so this stator winding, then what will happen? So current passes through stator current, okay, I stator, and produces one more flux in the machine. So this stator flux, so is, okay, this stator flux is a, so now this stator flux is a rotating magnetic field, RMF. So this rotating magnetic field. So how do we know this? So initially let us take, suppose, so we have a space, okay, like this. So this is a, the stator the rotor RMF. So phi r, okay, this one. So after that EMF induces in the rotor, in the stator. So this stator RMF. So after some angle, okay, this one we can say that. So current passes in this case, okay, I1 amount of the I1 current. So due to which flux will be produced in the stator. So that what we conclude here. So this phi r, okay, if it is a reference. So now phi s, the lags, okay, phi r, so by some angle theta 1, okay, this 90 plus the theta 1 here, okay. So this is a 90 plus theta 1. So but what about this nature of these two fluxes? So due to which, okay, due to this one, electromagnetic torque produced in the machine. So this electromagnetic torques, what will happen? Suppose here is the rotor part and stator part I will take. So it is a rotor and this one is the stator I have taken. So now this electromagnetic torque, so tries the stator, okay, this electromagnetic torque will be trying. So this electromagnetic torque produced by the machine, so this electromagnetic torque tries the stator, okay, this stator part. So in the direction of the rotating magnetic fields. Got it point? As like induction motor principle. So this electromagnetic torque produced by these two fluxes that tries the stator in the direction of the rotating magnetic field. But it is possible? No. Stator is a fixed body. So that whatever electromagnetic torque produced by this rotating magnetic field, so which is trying to rotate the stator, but it won't be happen practically, so that this force will be reflected on the rotor. So this will be reflected on the rotor and this rotor will be rotated in the which direction? Opposite direction to the rotating magnetic field. So in this case, so here is this rotor will be rotated in the opposite direction to the rotating magnetic field. So actually here, so this electromagnetic torque tries to rotate the stator, but stator is a fixed body. So that what will happen? Whatever force applied on the stator reflected back on the rotor. So that's why it will be rotated in the which direction? Opposite direction to the rotating magnetic field. So in this case, the rotor rotates in opposite direction. Okay, this opposite the direction to the rotating magnetic field. So rotating magnetic field at a speed of this speed of the n. So in this case also, okay. Very, very important point. All of it clear my point what I am telling you. So initially, first whenever rotor is excited with a 3-phase supply, rotating magnetic field produced in the rotor winding. So which rotates at a speed of the ns in the air gap. So as a result, the EMF induced in the stator in addition to the rotor windings. Got it point? So this EMF flows through the stator winding and produces one more flux in the machine. That flux is known as a stator flux. So the interaction force between the rotor flux and stator flux that produces electromagnetic torque in the machine. So what will happen this interaction force? So this interaction force tries to rotate the stator, but it won't be happen practically. So that whatever force applied on the stator to rotate, the reflected back on the rotor. So that rotor will be rotated in the which direction? Opposite direction to the rotating magnetic field. Okay. So for example, suppose if you there is a, let us take one ball. So let us take it is any cricket ball or volleyball or football or any one ball. Suppose if you force applied on a board, okay, this one is the let us take the ball. So now throw it to the wall. So wall is our stationary part. The ball is a force. So now we are feeling like a rotor. Suppose we are standing on the rotating part of the machine and throwing the ball to the stator side. So definitely what will happen? So this ball comes back to us. So now we reflected back. This force comes to back because of that stationary part. Suppose if it is a rotating part, definitely that the body will rotate in the direction of our force. Here force is a electromagnetic torque is a just like a ball. So we are pushing the ball towards the stator side. So but stator is a what? The stationary part. So that ball comes back to us and we will rotate in the opposite direction. अगर आपके पास एक वॉलीबॉल है, सो दीवार पे ऐसे पुश करो, सो बाद में क्या होगा यार, ये बॉल फिर वापस आएगा, वापस इस तरफ आएगा, हमारे अपने तरफ आएगा. सो ये दैट इज बॉल इज नथिंग बट इलेक्ट्रोमैग्नेटिक टॉर्क. सिमिलर वे, सपोज you are sitting on the rotor. Okay, we are sitting on the rotor and pushing, that is throwing a ball on the stator side. So ball in the sense electromagnetic torque produced in the machine. So this electromagnetic torque tries to rotate the stator part, but it is a stationary, it is a fixed body. So this ball comes back to us, we are on the rotor, so that we will be rotated. So this force will be reflected back on the rotor. So now tell me, is it rotates in the clock same direction of the rotating magnetic field or opposite direction of the rotating magnet? Is that clear my point? What I am telling you? Here no need to apply Lenz's law, Faraday's laws. So forget about the laws, just generalized theory. So how does torque produce? Then after, what will happen, this torque? So this driving torque rotate the stator, but stator is a fixed body. So that whatever force applied on the stator to rotate, it will be reflected back on the rotor. So that rotor will be rotated in the opposite direction. Yes, I hope you got it. So nothing difficulty here. So that's why it is treated as an inverted induction motor. Suppose in case of the stator field induction motor, what will happen? So just same example I have taken. So we are on the stator, okay, electromagnetic torque produced in the machine. So we are on the stator and pushing the ball, okay, or that is throwing the ball towards the stator side, rotor side. So rotor is a rotating part. So when force is applied on the rotor, so definitely rotated the rotor in the direction of the force. Okay. Similar way, so in the inverted mode, so we are on the rotor. So we are on the rotor pushing the force on the stator, but it won't be rotate. So whatever force applied on the stator, so definitely reflected back. Okay, that's why the rotor will be rotated in the opposite direction to the rotating magnetic field. No, after some time it is this reflected back, the electromagnetic torque produced in the machine. So similarly, this is a continuous process. Under steady state condition, the rotor is rotated at a speed of the n and in the opposite direction to the rotating magnetic field. If there is no supply, okay, supply is disconnected, it comes to the stop, but there is some excitation is given to the rotor winding. If the supply is a stop, supply is disconnected from the rotor winding, definitely it comes to the stop, but there is a input is already connected continuously, so that motor cannot be stopped. That's correct, good question, but supply is connected always, so that motor cannot be comes to the stop. If there is no driving torque in the machine, that time motor comes to the stop. Driving torque is present, but it is applied on the rotor itself only. Okay, have we got it? So now let us discuss about the equations point of view. Sometimes we have a question. So here at standstill condition, listen, at standstill means the rotor at rest position. The standstill in the means rotor at rest. The rotor at rest means the n is equal to the 0. Okay, here n is equal to 0. So where n is equal to 0 means, so now what about the slip here? The slip is equal to 1. So this is the rotor standstill condition. So in this operating mode, so rotor at rest standstill condition, what is the speed of the stator? Okay, this one is a speed of the rotor, so that is equal to the n. So here the speed of the rotor equal to 0, right? And what about the speed of the rotor rotating magnetic field? The speed of the rotor RMF. Okay, rotor RMF. So this is equal to, so 120 Fr by, okay, this here 120 Fr by the P number of the poles P here. So 120 Fr is equal to what? Okay, this is equal to, so where Fr is a, okay, in this case, so it is a supply frequency. Okay, in this case Fr is equal to, so in this case Fr is a, so Fr the supply frequency. So it is F in the sense the supply frequency. Got it my point? So this is the Fr value. So now the speed of the rotor RMF. Okay, rotor RMF. So with respect to what? Okay, with respect to the rotor at standstill condition. Okay, at standstill. Okay, standstill conditions. Got it? So this is the speed of the rotor RMF with respect to the rotor at standstill, and it is also equal to the speed of, okay, this is the speed of the rotor RMF. Okay, this RMF. So with respect to the stator. Okay, is that clear my point? So with respect to the here, speed of the rotor RMF with respect to the rotor at standstill. So at standstill condition slip is equal to 1. That's why Fr is equal to also, the Fr is equal to supply frequency. Now speed of the rotor, it is also equal to speed of the rotor RMF with respect to the stator. Okay, let's stop the lecture today here at this point. Tomorrow we will discuss about losses and power equation. That is a very important part, and you can expect the numericals from the losses and power equations of the 3-phase induction motors. Okay, so here we have only 2-3 questions. One is a find out the slip, or other one is a rotor frequency and rotor induced EMF. So these are the 3 questions. Sometimes the question about the slip, question about the rotor EMF, rotor frequency, and other one is a rotor induced EMF under running condition. Under standstill condition, so standstill S is equal to 1. So that is the standstill rotor induced EMF, it is equal to E2 only. But running condition induced EMF is the slip times of the standstill induced EMF. Okay, tomorrow we will discuss about losses and power flow equations of the 3-phase induction motor. That is a stator. This is the only special case, the rotor fed induction motor. Any more question do you want to ask? Otherwise, let's stop the session and we will discuss tomorrow. Let me complete this part, and after that I will try to take the class in the main channel. So first we have started the induction machine part discussion, and let us complete this part. Okay, and then after I will discuss the DC machine in the main channel. Okay. Any more question do you want to ask? You can ask, otherwise let's stop the session. Operation is a very important and principle, no need to confuse. So here in the stator fed induction motor, electromagnetic torque applied on the rotor from stator to the rotor side. Here is a rotor fed induction motor, electromagnetic torque applied, electromagnetic torque produced by the machine applied from the rotor to the stator. Just imagine yourself, you are on the rotor and applying the force on the stator. So then what will happen? So here stator won't be rotated, but it will be whatever force applied on the rotor. So force means just like a ball. Okay, if you applied, so this if you throw it to the stator, then it comes back. So what is your question, Dasu? You can ask. What is your question from the transformer? Okay, what is your question? Okay. So what is your question? Tell me, we will discuss. If the flux is a square wave, EMF induced in the transformer is also square wave. That is a, but what will happen? Some displacement takes place. EMF induced, shape of the induced EMF is a square wave only. So, but displaced by, okay, displaced by 180 degrees. The supply voltage is a square wave. The EMF induced in the transformer is also square wave. I have discussed this question in the first class of the transformer. Okay. Okay, any more question? I think you don't have any questions. So thank you. So thank you very much, and we will meet tomorrow at the same time, and we will discuss about power flow equations of the 3-phase induction motor. That part is a very important for computer exams. Okay, try to attend the session, and if you like this session, share this session to your friends and classmates, okay, and to reach the maximum maximum aspirants. Thank you very much.